regarding the data mining. So as far as the textbook was concerned, we were mentioning that it is with Han and Kamber. So you can see the author's name, etc., credentials, etc., and the courses what he has been teaching. And we are following his uh, textbooks, etc. And yeah, before why we move to the data mining before we look for the databases was it was with tremendous growth of data right from terabits to petabits, and automation has been everywhere. Automation earlier was not there, but now automation is everywhere, and uh, live locations, everything sitting at our home, we were able to operate the environment around us. So at that time, conventional databases may not be suitable to such applications. So that's the reason why the collection of data and availability of data has to be migrated to the automation content. Now, what will be the prominent usage of data mining means? Yeah, it will be for businesses, scientific locations, and many social media platforms, etc. So the journey for the databases, the journey for the data warehouse was, say, we have an empirical science without proofs, then theoretical science with some proofs, experiments, etc. And the generation for us, that is, we are at the computational science. So everything is verified, everything is authenticated until unless it is proof, until it is a realistic way people aren't believing. So beliefs was at this empirical science. So that's the reason where computational science with an interdisciplinary growth, etc., it came into the stimulus. The word coined of data science, we mentioned, it is with the technology of big data, followed by data mining and machine learning algorithms. So these are the key ingredients or components for the data science, and as part of it, we will now look the domain called as data mining. So the history, what it was telling was in 1960s we have the databases, 1970s relational database management came into existence, 1980s RDBMS was used in scientific and engineering applications and business domains, etc. In 1990s, it is upgraded to data mining, warehouses, multimedia, and right now it is with social media and data science and etc. So this is what a generation-wise content which is meant for the growth of databases to data mining happened. So when we are going to take a word called as data, then it was processed to information, and then it was towards DBMS, which it was extended to relational database management systems, advanced database management systems. So when it is advanced management system, it is hierarchical, it is network, it is object oriented databases, etc. And then it was migrated to data warehouse. It was migrated to data warehouse, and then it went to clouds. So this was the vertical incline of data. This is what the vertical incline of the data. So first we have data, next it is processed to information, then the database management system, followed by advanced database management systems, where we are going to have hierarchical, network, and object-oriented database management systems, and it was extended to data warehouse and followed by the cloud technology. So every subject you are going to learn as part of your computer science. So that is where you should understand right from the seed, right from the root, you should understand what's the flower. So every growth of a technology where you should understand as part of the engineering. So this is what a table which is moving up with this evaluation of the database.
Sir,
Yeah, pardon.
screen is not sharing, sir.
Okay, I will just share it again. I think my screen is sharing.
Yes,
Yes,
sir.
sir.
So I just recap one illustration, then I will go to back there. So I was mentioning we have a data here. From data, it is converted to information. From information, it was meant towards the So from database management systems, it went to relational database management system, and from relational database management system, again, it went to so there are some network issues where the content is tripping off, I understand. So it is a network issue. So four with the DBMS, we have relational database management, object-oriented database management, hierarchical database management, network database management, etc. Thereby, we will be having the fifth layer called and from that database it was extended to so large databases. From then it went to so the essence what I was mentioning was at this point, that is evolution of database technology. It is right from creation of data, collection of data, extended to database management system, thereby to the advanced database management systems, and then moved to the web-based systems. In this way, finally, it is going to integrate it with the cloud, etc. So all these implicate to analyze the data to get some good insights for the data. So we have the basic definition of what was data mining here. So data mining definition, it is part what we were going to call. It is going to be a non-trivial content. It is going to be a non-trivial content followed by an implicit, and the hidden patterns we don't know. From that we are going to find pattern, we are going to mine knowledge, and thereby we will be having potential information. The alternative names for data mining, we will calling it as a business intelligence. So here you can see the diagram, people are going to mine, and then they are going to find the knowledge. So that's the symbolic representation of what was this database, etc. It is going to mention up. A quick recap of what is knowledge discovery in databases. So as far as knowledge discovery in databases is going to concern, so the very first thing you should understand will be the essential part. So the essential part will be one, we are going to call it as data. So data can be brought from databases, data can be brought from databases, data can be brought from flat files, data can be brought from clouds. Three things are going to be there. One, data can be brought from databases. Two, it can be brought from clouds. Three, it can be brought from flat files. So you are aware that what is database? Okay, fine. Then you are also again aware of cloud. So Google Drive is a cloud. Pen drive, the OneDrive is going to be a cloud. Similarly, Amazon Web Service, AWS, is a cloud, and in this way we have Azure platforms, etc. From those we will be able to bring the data. Okay, fine. I have first from my local disk, second from .dat file, dot comma separated value file, dot attribute related file format file, or dot text file. So from these all way we are going to represent it in a notepad, and then we are going to give the things we call such information as flat files. Thereby, now we have databases, we have flat files, we have clouds. So now what I have to do is I have to integrate them. I have to integrate them. So 1 plus 2 plus 3, now all together it has to be fit in a word called as data warehouse. So multiple locations data is available. From those multiple locations I have to bring data, put it together, and then I have to unify the content. So students will come from various parts of the state, various parts of the country, but still we are going to put a unified language called as an English. So your mother tongue can be Telugu, Hindi, or Tamil, etc. But we are putting them together and bringing to a unified language called as an English, and thereby we are starting a class. Similarly, we have databases, we have flat files, we have clouds. Everyone are having their own version of storing the data, but if I want to do some implications, I have to make them transform. I have to make them loading, I have to make them extraction, I have to make them extraction, I have to make them loading, and then I have to go for transaction. So 3 words has to be propagated at this content. So the first word, what I am going to call it as extraction. The second word, we are going to call it as transformation. Third word, we are going to call it as loading. So E, T, and L, we are going to call this word. So I have first database, second database, third database. I need to make integration. I need to make integration. After integration, I am going to apply extraction, transforming, and loading. All together we call here as data warehouse. So this is the fundamental step. So some students will talk Telugu, some students will talk Hindi, some students will talk Tamil. Now I am going to have 3 set of students, and all the set of students have their regional languages. But when I are to my class, I should focus that the language what I talk should communicate to them in a same way. So thereby I am going to put my own language here, and that language will be communicated to these. So bringing them together, putting them together will be done with a process extraction, transformation, and loading. So that is going to be the major part of the larger databases, which we are going to call here as the database. So we talked about the first word, integration. Then we are doing this with databases, and missing data, null values, etc. are going to be removed. We are going to call them as data cleaning, and up to here, everything is going to be set. So this is what we do at the root level. This is what we are going to do at the root level. Thereby we are going to apply task specific content. So what is task specific content means? Now I need to apply the machine learning algorithms. I need to apply machine learning algorithms. So the part where we are going to classify the things in machine learning algorithms, those we are going to call it as some association, followed by classification, followed by clustering. One, we are going to call it as association. Two, we are going to call it as classification. Three, we are going to call it as clustering. Okay. Now let us say there is an almara, there is a book rack, where we are going to put the locations here. So I will just say I have a textbook called as computer cloud computing. Then I have a textbook called as data mining. So I have data mining textbook 1, textbook 2, textbook 3, and textbook 4. Cloud computing, I have textbook 1, textbook 2, textbook 3. So here in the Almara or in the book rack at the library, it will show cloud and they will show DWDM. Now here I am going to have the stickers, I am going to have the labels here, I am going to have the labels here. So this is what we are going to say, they are classified, predefined. So as the label is going to be mentioned earlier, as the label is going to be mentioned here, so what the textbooks you have, those textbooks you are going to bring it and put in the same Almara because the label is available. You know where to put these books, so the label is available, you are putting there. Similarly, I am going to have my data mining sticker or a label attached to the Almara there. Therefore, all the data mining textbooks we are going to put there. So obviously, you are going to apply a word called as classification, and the technique we are going to call it as supervised learning. I am going to call it as supervised learning. So we have three techniques at this point of time. Supervised learning. In supervised learning, what we are going to do is we are going to make a labels, and once the labels are known in advance, labels are known in advance. So that is what the importance, it is like a guru. So obviously people are there, okay, there is a label, go and put the books there. So obviously you don't worry about it because already labels are there, so you are going to do it. So that is not at all a problem. So in such a case definition, we are going to call here as a supervised learning. The next category we are going to call here as an the next category we are going to call here as clustering. Clustering, we don't have a guru, we have to do it on ourselves, we have to make categories on ourselves. Therefore, we are going to call it as a unsupervised learning. We are going to call this material as an unsupervised learning. So when we are going to say it is an unsupervised learning, what happens was that, so assume that I am going to have a background like this. Now I have putting like this, okay, 4x's in this yellow color. Then I am going to have some red color here. So I will put some dots here. I will put some dots here. I will put some dots and crosses, etc. here. So which are going to be in a red color. Then I am going to take some green color, and this green color, what I am going to do is I am going to put some again green colors here and there. So now you can see at this point of time green colors are going to happen. Thereby I am going to take a white color here. So again I am going to put some stars here, white color stars here. So now the thing I am going to say here, the question was group according to color. Now the question was group according to color. So you don't know what exactly the color definition, you don't know what is green, you don't know what is red, but you will find some similarity. You will find some similarity here. So based on the similarity, you will make a segregation at that point of time. So when you are going to make a segregation, what you are going to do is you will put all the white content at one group. Then what you will be doing it is you will put all the yellow stars, or you will put all the yellow stars So you will put all the yellow stars at another group here. So the second group you are going to take up, and then you will form the third group as a red group, and then again you will segregate this red group as one thing, and finally you are going to put this green again into another group. So now in this way a uniformity is going to be rendered at this case. So you can see here, first group it is totally in one location, second group it is put in an yellow way, third it is going to put it in green, and fourth one it is in red. So even you can try with the kids, if you are having with your siblings, with your sisters, kids, etc. You put the Legos before them and you ask them, you sort the Legos. Even the 1 year kid don't know what is red color, 1 year kid don't know what is green color, blue color, yellow color. But if you are going to place before him and you tell him to organize, he will put all the things white into one group, he will put all the yellow things into one group, or she will put all the red things in one group, or she will put all the green in one group. So what is the knowledge he is going to have? He has seen somewhere else where he discriminates the colors. So how he is going to discriminate the colors even without knowledge? Where he is going to, in his
Sir,
mind,
you're not
he is like,
audible. Sir.
I am not audible.
You are audible, sir.
I am audible. Okay, fine.
Audible,
So
sir.
yeah, thank you. So that 1 year kid, he is going to make similarity. So he is going to segregate these contents, all the yellow colors into one group. He will make this red group, green group, and white. So how he is going to do means he is going to have his brain with an algorithm called as similarity, and in that similarity he is going to apply a concept of unsupervised learning. He is going to make a unsupervised learning, and that too he is going to use the algorithm called as clustering there. He is going to apply the clustering technique. So even though he don't have any predefined information, but still he is going to able to make a group. So that grouping he is going to do with similarity. So he has brought all the whites together, put it in one group. He has brought all the greens into one group. In this way, he is going to discriminate the things where cluster analysis has that foundation. So we say that word has an unsupervised content. So the third thing we will look here will be the association. The third thing was we are going to look at will be the association. When we are going to talk about the association content, when we are going to talk about the association content, the foremost content was that if I am going to buy a pen and if I am going to buy a book, if I'm going to buy a pen and if I'm going to buy a book. So obviously, the next thing was the persons who buy pen or a person who buy a book. So here is a pattern. Similarly, if a person purchasing a milk, person purchasing a bread, so obviously he may go for buying jam. So there are some patterns where pen and book, maybe he is also buying some pencil, etc. So the algorithm will tell that the girl is purchasing this dress, the girl is purchasing this dress, so she will purchase a combination dress, this one. So in this way, the pattern analysis happens where we are going to call as association. So red dress has been purchased. Obviously, the item will be purchased will be a red nail polish. So you will be looking at an associated way. That's the reason why in shop, etc., the buying patterns, the trend are going to be analyzed. So the colors has been justified, and based on that, what will be the next item they are going to be procured. So that is where the people in the supermarket, they will organize the things one after the other, one gallery after the other. So all the items, so if you are purchasing these two items, the next item, what in your mind, they will be displayed in the next rack. So how it is going to do means they are going to do with a word called as an association. And how they are going to make this association means, again, they are going to apply the machine learning algorithms. In this machine learning algorithms, they are going to apply a priori algorithm, or they are going to use frequent pattern algorithm. So people, they will apply the frequent pattern. So repeatedly, most of the people, what they are going to do, based upon that, it becomes a habit, and next people also will do the same. So obviously that prediction is going to happen in the data warehouse, and it is going to be coming into an actionable insights in form of machine learning algorithms, where they are going to use association with a priori algorithm and with the frequent pattern algorithm. So this is how the basis of the data mining came into picture. So finally, the knowledge discovery in databases will have its imprints with bringing up the pattern, in bringing up the knowledge. So buying red dress will also purchase red nail polish. So obviously this is the pattern, this is the knowledge what it is gained. So this, where we have data marts in shopping malls, big data warehouses in shopping malls. So the mostly they apply the machine learning algorithms. When you procure the bill, you can check in when you visit your Reliance Mart or other contents like KLM or whatever you see in Bhimavaram, etc. So every item what you have, they will be having a code. So they will give you a bill, you leave enough, and that will be brought to the data scientist, and he will look up what items you have brought. So you purchased X item, you purchased Y item, you purchased Z item. Then he will associate what is the relationship between X item, what is the relationship between Y item. So in this way, he will find the pattern of 10 customers, and from the 11th customer onwards, he will put those side by side, so that the pattern will make him money. So this is what he is going to say, a word called as a business knowledge, or we are going to call it as business analytics, or we are going to call it as business intelligence. So they identify the customer knowledge, and that is where mostly the data science or a data mining is going to play. So coming to the business intelligence part. So we talked about data sources. Data sources can be from flat files, which are going to be flat files, which are going to be part of um, uh, the two-dimensional way in Notepad, etc., like comma separated values. So you will be using CSV files, etc. So you are already doing Coursera courses, etc. There you are taking data sets, and data sets are stored in .csv, comma separated values. So comma separated value is nothing but we are going to call them as a flat file. And similarly, the next level was it goes with the collection of data from the internet agencies. So where we are going to say it is from Facebook, or it can be some Twitter tweets, etc. And there we get an unstructured data, and that unstructured data is going to be normalized and stored it in structured format in rows and columns at database systems. So all that process, it is going to be done as pre-processing and integration. So this entire component, we are going to call it as ETL process. We will be calling it as extraction, transformation, and loading. I was just mentioning, we will be getting data from multiple sources. We will put them into a single unified format, and that single unified format, we are going to call it as data warehouse. And thereby, we will be looking statistical operations like mean, median, mode, etc. So in Python also, when you are going to make a .csv file, then the first step you will put it as summary. So or in R language also, you will be putting a summary of the database. It gives IQR, it gives mean, it gives median, mode, etc. All those, it is going to be part of the reporting and querying and exploring what are the contents inside the data. So this is what we call it as data exploration. So finally, we are going to apply the association techniques. We'll be applying the supervised techniques, or we are going to use the unsupervised techniques. And this is where we are going to call it as data mining, or you are going to perform the data analytics part. Thereby, we need to present the results. How we are going to present the results means we can present the results in bar charts, we can present the pie charts, present the results in pie charts, or with an Excel where we can have some rows and columns. We will be having rows and columns. In this way, we will be having storytelling content. We will be having storytelling content. So, what's happening inside the data? You need to bring up that in a concise way, where the end user, he can be able to understand, where the end user, he can be able to understand what is happening inside the database, and there he can come up with a decision whether to bring money. So what type of decision he can make, whether he can give some discounts for the sales, or whether he can put the same margin. In this way, he has to go with some actionable insight. So for that, he is going to make a decision. So this is all regarding what we are going to call here as a business intelligence. So decision making, or we are going to say the presenting of knowledge, is going to be the most important part. So the potential support for decision making is going to be done at underlying, we call it as data warehouse. Above it, we are going to call it as data mining. So both these two are bringing with data visualization, and then they are going to bring up to the decision making. So this is all regarding the business intelligence. So I just mentioned here how we are going to communicate means one, it can be with databases, two with the data warehouse, three from unstructured data. All of them, they are put together, they are integrated. We will be getting it as ETL process, and thereby they are stored in large repository. So large repository. So this large repository, we are going to call it as data warehouse, and thereby we are going to do data mining with data mining engine, where we will apply association, we will apply clustering, we will apply classification, and we will find the pattern, and there we will forecast the future. So we will be having here the historic data. We will be having the historic data. From this historic data, we will make some predictions. For example, my 1-1, I have this marks, 1-2, I have this marks, 2-1, I have this marks, 2-2, I have this marks. So then I have 3-1, these marks. So my percentage is 9, here CGPA, here it is 8, again it is 9, again it is 9. So it is 9. So now this is what the historic data. My previous semester marks are like this, 99998 is going to be my historic data. Now what will be my marks for 3-2? So I will be doing some aggregation, and I can say it is again around 9. In this way, I am going to forecast the things. So what is pattern here? I can say 9-8, 9-8, 9-8, and I find the difference, and then I am going to get the knowledge base. In this knowledge base, I will apply association, clustering, or classification algorithms, and thereby I am going to communicate it to the end user with the graphical user interface. So another typical way of presenting the things will be with machine learning and statistical analysis. One with machine learning, two, it will be with statistical analysis. So what we are going to call was, before we are going to work on the data, the first and foremost condition was we need to clean the data. So before processing, this is using, and after processing. So here we are going to call it as pre-production, then this is production, and this is post-production in terms of your movie words. So post-production. So before what the movie has to be there, etc. Here movie is characterized, and there they will add after effects, graphics, dubbing, etc. So similar way we will be having before processing, after processing, and the current stage here. So before processing, we will be call it as pre-processing techniques, and at the main stage, we will be using the data mining techniques, and then after processing, we will find the pattern. So this is where a relationship has to be built. So in making this relationship built, we will use two words. One we are going to call it as machine learning, and then other word we will be using the other word along with machine learning, we will be using the statistics. So lot of mathematical foundation should be there in order to get the data from pre-production to the actual execution and thereby to the post-production. So the diagram itself here, you can see here what will be the techniques if we are going to do for pre-processing means, yeah, it will be with integration, data integration, it will be with normalization, then it is going to be with feature selection, then it is going to be with dimension reduction. So every word is a topic which we will be discussing one by one hereafter. Similarly, the contents what will be for the data mining. Yeah, we talked about association, we talked about clustering, we talked about classification, and finally we will be looking at a pattern. So that is all a part of data discovery, which we are going to do it as a part of a data mining. And okay, fine, I have turned the pattern, I have found the pattern, I got an insight. Now, how can I use it? So it is what we call it as evaluation, we call it as pattern selection, we call it as pattern interpretation, and finally, how we were able to understand the pattern, we are going to call that word here as a data visualization. So all these are going to be the most important and prominent parts of the knowledge discovery in databases. So the very first thing with the integration, when we are going to call it as an integration, when we are going to call this word as an integration, so we will have data from multiple sources. So one, it is going to be cloud. Two, it is going to be database. Three, it is going to be from flat file. Three things are there. Now all together put C plus D plus F. So we call this one as integration. This is first fund. Next one, the word we have to look here will be normalization. Again, what is normalization at this point of time? So when we are going to call here as normalization, so I have the habit of putting the things in 100. Other people will write the word in 100.00. So I will be using without decimal, another will be using the things in decimal. So I need to adjust a scale such that all the values should occur between 0.0 and 1.0. All the values should be brought between 0.0 and 1.0. We are going to call here as a normalization. We are going to call here as a normalization. So my percentage is 90%, another percentage is 91%, another was 92%, another was 93%. So what will happen was the values has to be normalized. So how can I go for normalization means I can get it as 0.90, 0.90, 0.91, 0.92. So actually I am storing the data in percentages, but if I want to make it as an integration, if I want to go for integration, then I have to go with a word called as normalization, so that I have to bring them in a unified format. So this structuring we are going to call here as normalization. The next one was feature selection. So the next one was we are going to use a word called as a feature selection. So in this feature selection, what we have to look was feature selection and dimension reduction. So these two words are again interrelated words, feature selection and dimension reduction. Assume there is a table with register number, name, then I have 10th class marks, I have inter marks, then I am going to have BTech marks, then I am going to have blood group, then I have some mobile and email, etc. Then I will have in this model. So this is the table here. So register number, name, 10th class marks, intermediate marks, BTech marks, blood group, mobile number, email, and again MSET rank. Okay. So this is the table what I am going to have. Assume there was a query for you. So what was the query was? Give me list of students having blood group is equals to O positive. So this is the query what I am going to have. So there is a database table with MSET rank, registered number, name, 10th class, BTech, intermediate, mobile number and email. Now for this query, give me the students who have blood group is equals to O positive. Give me the students names who are going to have blood group O positive. Now, is there any meaning in considering 10th class marks? Is there any meaning in considering intermediate marks? Is there any meaning in considering MSET marks or BTech marks? So what features are needed to my query, only those features I will be taking up. So the feature what prominent it is to me means the feature which is going to be most prominent will be the blood group. Therefore, I will be using only the blood group and remaining I will be using the register number. So what happens was I take the features of name and I am going to use the feature called as blood group. And if I want to contact her, so that I need some contact information, maybe I will be taking the mobile number. So these three fields are enough for me to make my relationship. Therefore, feature selection was I have a superset. From that superset, what features are there to complete the task. So what is the task means? Give me the student names who are going to have the blood groups of O positive. So there is no meaning in making analysis with MSET marks, with 10th class marks and BTech marks. So I am looking for the student who is having blood group of O positive. So remaining features can be eliminated. Remaining features can be neglected. So that word we are going to call here as dimension reduction. That word we are going to call here as dimension reduction. So in order to make dimension reductions, what I can do was I will eliminate the columns. So what will be the eliminated columns means it will be 10th class marks, inter marks, AMSET code, the BTech marks, the register number. So these items are unnecessary, time consuming, occupying much CPU time, occupying much memory time. So such type of items has to be eliminated. So give me a name for it. You have a name, I have a name. So to put a name for that, they have given a name, and that name we are going to call it as dimension reduction. So in dimension reduction, a task is given. For that task, what are the specific fields we have to give? Only those specific fields I am going to give. That is what we call it as feature selection. For that task, unnecessary items are eliminated. So unnecessary items what we are going to get has to be rejected. That is what we are going to call here as dimension reduction. So in our case, the data pre-processing, what it is going to do is, it is making integration, it is making normalization, it is going to do feature selection, it is going to make dimension reduction, so that it is making data pure. It is going to make data pure, or it is going to make data mangling, or it is going to call it as data cleaning. So all are called as acronyms. Data mangling, data cleaning, because when you do your course, era course, etc., they say data pre-processing, there they will call it as data mangling, etc. So that is also a part of what we are going to call here as data pre-processing. So that is missing data, unwanted data, unrelevant data, not available, null. So such type of misleading values has to be removed to do analysis. So all that part, it is going to be taken up in data pre-processing stage. Now we will be getting pure data. We will be getting exact data for analysis. So what is analysis here means, the main intention was to find hidden patterns, to find what is inside. So you make a diagnosis, a fever was there for a X person. Now their doctor is recommending some diagnosis. So he is going to identify where exactly it went wrong. He is going to make some discovery on him. So where the pattern, the symptoms of whether it is a disease or not, he has to identify it. So that is where we are going to call it as pattern. Okay, fine. How he is going to identify? He is going to identify machine learning techniques, and that they are going to call it as association. We are going to call it as classification, clustering, outlier analysis, which doesn't have a normal behavior, which we are going to call it as an abnormal behavior. So 10 flocks will move in one side, only one flock is going to move it in another side. So that one flock behavior, we are going to call it as an outlier. It can be great, extremely great, or it will can be extremely discouraged. But both of them are going to mingle, which we are going to call that word as an outlier analysis. So data mining primitives, they can go with data discovery, with association, with clustering, with classification, and with outlier analysis. They are going to be applied. Fine. What I am going to get? I am going to get knowledge. I am going to discover intelligence, etc. How do I do it? I am going to produce it with data visualization. I am going to put it in graphics, where I can evaluate the pattern, I can select the pattern, I can visualize the pattern. So it will be a mere understanding of an end user. So that is where the data visualization or a pattern visualization is going to come into picture. So where are the applications of data mining? Yeah, there are going to be applied with some medical domain, where again the techniques are going to be applied. And what will be the different examples towards looking with the data? There, it is right from relational databases to warehouses to traditional databases, and where exactly the data can be brought for analysis. It can be brought from object oriented, it can be brought from time series, sequential data, the geospatial data, graphics, etc., or from web, we call it as text mining, the PDF data, the Word data, you can be analyzed, we call it as text mining. And then to have animated data, image data, audio data, video data, we call it as multimedia data. So all these are going to be the different forms of data which we will be looking tomorrow. So a quick recap of what we have done for today. We have coined the two words. We have coined the two words. The first word we coined will be the data mining. Then we had an empirical study. What is it at 1600 without proofs, without beliefs? So it is a methodological way. People will tell, okay, don't touch. So there is no proof for that. Why we shouldn't touch? We have a lot of ambiguities in our brain. Why this person is telling don't touch? Then theories came, but still experiment results were not successful. But now when it is put to a computer, everything will have a proof. Everything will have a belief. Why that those people told not to touch? So obviously now it is materialized with a proof. So that came from 1950s to our generation. So that is what we call here as a computational science. And thereby looking at the databases, earlier it is flat files, and then it went for the DBMS, then it went for relational databases, and thereby the data mining and data warehouses techniques are taken place. Now it is big data, data science, clouds, etc. So this is the evaluation diagram what we have discussed, and thereby we went with the core definition of a data mining with trivial, implicit, unknown patterns, etc. And the most important thing that will be the different stages of the knowledge discovery in databases, right from cleaning to warehouse, applying data mining primitives, finding the hidden patterns, trends, giving insights, where we are going to call that word as a knowledge discovery. So we went with what's the relationship between data mining in business intelligence. So obviously, in order to take good decisions for business, people are going to adopt the data mining techniques. So data will be brought from multiple sources. It will be cleaned. It will be explored. The data mining techniques are processed. Hidden patterns are visualized, and people will make a good decisions over it. And then the same diagram we were talking in another model. And finally, we talked about the pre-processing and post-processing contents. So where pre-processing techniques, it is part of data mangling, data cleaning. Pure data is going to be brought for analysis with different types of techniques, and post-processing, we have pattern analysis and visualization, etc. So this is all what we have talked for today, and the next class we will be talking about the different kinds of data, etc. So we have 143 students turned for this.